All right, last lesson of the chapter, applications and models. So here we're going to be working with surveying and navigation, and directions are generally given in terms of bearings. All right, now at first this tends to be a bit of a confusing concept for students, but let's break it down. All right, so a bearing measures the acute angle, all right, so meaning less than 90, that a path or line of sight makes with a fixed north or south line. For instance, the bearing south 35 degrees east means 35 degrees east of south. Okay, so you're probably still wondering like, okay, well, what does that mean? All right, well, let's look down here at some examples. So here's south, 35 degrees east. So you start from south, all right, that's your first letter. So I'm starting from south, and then from there, I rotate 35 degrees going to the east. So rotate 35 degrees. And now this blue line here, here's my arrow. This is the direction I'm headed then, where the arrow is pointed. All right, that's south 35 degrees east. All right, a couple more examples here. All right, you always start with south or north, okay? It's one or the other, and then it ends with east or west. All right, so here we're starting at north, and then I'm rotating 80 degrees going west. So rotate 80 degrees, and so this is the direction I'm heading. And then there's north, start at north, and I rotate 45 degrees east. So this is the direction I'm heading. All right, it's pretty simple once you get the hang of it. It's actually really simple. All right, let's go and do an example. All right, so a ship leaves port at noon and heads due west at 20 knots, okay, or 20 nautical miles per hour. At 2 p.m., the ship changes course to north 54 degrees west. Okay, so this is where the ship starts from and goes for 2 hours, and then it changes direction. All right, now we know this is 40 here because it's going 20 nautical miles per hour, and it started at noon, and then it changed direction at 2 p.m. So it's been traveling for 2 hours, so 2 times 20, we get 40 here. All right, then it changes direction, so north 54 degrees west, that's going this way now. All right, once again starting here from north, and then you rotate, all right, 54 degrees west. All right, and this is where the ship is now. Okay, so find the ship's bearing and distance from the port of departure at 3 p.m. All right, so it traveled for another hour, so it's traveling 20 nautical miles. So that's why this is 20 here. So 2 hours, 40, 1 hour, 20. All right, now, this is what you need to understand. What's the bearing and what's the distance? This is the distance in green here from the point of departure. We need to figure out that distance. And then we need to figure out the bearing. So what is the bearing going to be exactly? Well, let's see. It's headed north. All right, it's headed north, but then a certain amount of degrees west, all right, because we're going to left. So it's north, west, right? It's in this region here. That's where we are with the boat. All right, so we got to figure out this angle measurement here. All right, how are we going to do that? Let's see what we have to work with here. Well, if I figure out this length and I figure out this length, notice that this whole thing is a big right triangle here. I could combine these two lengths here, and then I have this one, so I could use the Pythagorean theorem and get C, all right, which is the distance from the point of departure. So let's try to do that first. Okay, what are we going to do? We got this right triangle on the side here, all right, and that's 54 degrees. This is 90 here, so this must be 36 degrees, all right? It's just 90 minus 54, 36 degrees. Okay, all right, so now I want to figure out D, so I'll use cosine because this is adjacent. This is, oh, come on, this is opposite. All right, that's your hypotenuse. All right, so I'm going to use 20 cosine 36 degrees. If you're not following any of this, just call me over so I could clarify. All right, so now I'm going to multiply by 20 on both sides. Okay, so I had cosine of 36 is equal to d over 20 to start with, multiplied by 20 on both sides. And then I have, what do I get from that? D is equal to, make sure your calculator is in degree mode. All right, 16.2. That's an important piece of information. And then I'll figure out the opposite, right, which is b over 20. Multiply 20 on both sides. So I get b is equal to 11.8. All right, got those. All right, now I combine d and 40, and that gives me 56.2. All right, so now I could figure out the distance from the point of departure. So I use 11.8, all right, which is this length here. I use this whole length, squared plus 56.2 squared. All right, easy stuff. Let's figure out C. C is going to be 57.4. Okay, cool. That's a very important piece of information. All right, now I have to figure out how to get the bearing. Okay, I'm going to figure out this angle first. Let's call this omega. Okay. And how am I going to do that? All right, I got opposite. I got adjacent is 56.2 for this big triangle. Okay, so I have tangent of omega is equal to opposite, which is b, which is 11.8, over 56.2. Okay, what do you do when you want to get the angle measurement by itself? You can't divide by tangent, okay? Like, these two are stuck together here. There's nothing you could do about that. All right? Nothing you could do about it, except apply the inverse tangent, and that essentially breaks them apart. That's the only way you break them apart. So apply inverse tangent to both sides. All right, and then you've isolated omega. All right, that's what the inverse trig function is for, to figure out an angle measurement. Can't emphasize that enough. All right, so then figure out the inverse tangent of 11.8 over 56.2, and we get 11.7. All right, it's 11.7 degrees. So now if I want to figure out theta, this is 90 degrees here. Okay, so all we have to do is 90 minus 11.7, and we get 78.3. All right, which is the bearing. So now the distance from the point of departure is 57.4 nautical miles, and our bearing is what? Well, we either start from north or south. We're starting from north, and then it's rotating 78.3 degrees, going which direction? West. All right, and there's your answer. Let's do one more example. All right, working with simple harmonic motion. All right, don't get thrown off by these formulas here. All right, they're just variations of what you're already used to working with. This is your amplitude here. This is your b value. Instead of b, they're writing omega. Don't freak out. All right, and then here's 2 pi divided by what used to be b. Now it's omega in this case. And then the new piece that we're learning about is frequency. And frequency is simply the period formula, but the opposite of it. So b over 2 pi. And frequency is just the number of cycles per second. All right, let's do an example. All right, now it seems like there's a lot going on here, but let's break it down. It's actually quite simple. They say it takes 4 seconds for this spring to oscillate, make one complete oscillation. All right, so here we're starting at the equilibrium point. And notice what's happening with the spring. If this is the path of the spring, if we graph it out. All right, as it bobs back and forth. All right, you actually get a sine wave. All right, now notice that this distance here is 10, so that's your amplitude. And right here we know that it took 4 seconds. Okay, so using our formula D, this is a sine function since we started off at the equilibrium point, A sine omega t. All right, so our A is 10, and I need to figure out the omega. Oops, sine WT. Okay, I need to figure out the omega, and how am I going to do that? Well, I know my period here is 4 seconds. All right, period is the amount of time in this case it takes to complete one full cycle. All right, so I already know that my period is 4. But what's the period formula? The period formula is 2 pi over b, or in this case, omega. So I multiply by omega on both sides. I get 4 omega equals 2 pi. Divide by 4, and omega is equal to pi over 2. All right, so that's an important piece of information. Now I can complete my formula. 10 sine omega is pi over 2, and then t. Done. And t is just like x before. All right, and the last idea is frequency, which means you just flip the period formula, which is omega over 2 pi. And what is omega in this case? It's pi over 2 divided by 2 pi. So we have a complex fraction here, simple stuff. End up with 1/4. So the frequency is 1/4 of a cycle per second. And that should make sense, okay? All right, because frequency just means how many cycles per second. Well, this is 1 second, 2 seconds, 3 seconds, 4 seconds. At 1 second, how many cycles do you have? Well, this is just a quarter of the cycle. So that's why we have 1/4 of a cycle per second. All right, so that's all there is to it. If you have any questions, please make sure to ask. Begin the assignment at the bottom of the webpage.